In this video, we're going to continue looking at metabolism in the cell, and in particular, we're going to look at the thyroid and the parathyroid glands. The thyroid gland is a fairly large gland located in the neck, and it produces triiodothyronine, also known as T3, and thyroxine, also known as T4, which are hormones. And they require high levels of iodine, which is acquired from the bloodstream. And iodine in the bloodstream, it comes from food that has been consumed, and iodized salt is the primary source. And in fact, that is generally why salt or iodine is added to our table salt to ensure that most people are going to get enough iodine. So T3 and T4, they increase metabolic rate by stimulating cells to break down more glucose and use more energy. The thyroid, it also produces the hormone calcitonin, and calcitonin is released when blood calcium levels rise, and this promotes the deposit of calcium in bones, and we'll look at that again in just a moment. So with the parathyroid glands, they're embedded behind the thyroid gland, and they produce parathyroid hormone, also known as PTH. So PTH, it causes blood levels of phosphate to decrease, and PTH also increases blood calcium levels by promoting the release of calcium from bones, the reabsorption of calcium in the kidneys, and calcium absorption in the intestine. So here is a diagrammatic kind of a loop as to how the blood calcium levels are maintained at their optimal level. When blood calcium levels rise, it causes the thyroid gland to secrete calcitonin into the blood, which causes the bones to take up calcium from the blood, thereby decreasing calcium levels in the blood. Then if calcium levels decrease, if they are low, that causes the parathyroid glands to release parathyroid hormone, or PTH, into the blood. And PTH has several effects, which we mentioned. It causes the bones to release calcium into the blood, also causes the kidneys to reabsorb calcium from the kidney tubules, and causes the kidneys to activate vitamin D, and the activated vitamin D acts on the intestines to absorb more calcium from the digestive tract. Thereby, all of those different factors increases the blood calcium levels, thereby maintaining homeostasis. Calcium is important for a number of things. We often associate it mostly just simply with the calcium levels in our bones, but it's also a cofactor actually for many enzymes. So it's also needed in that regard as well. So maintaining optimal calcium levels is absolutely crucial. And so you can see here we have these two feedback loops which maintain the calcium at optimal levels. So we've just looked at the thyroid and the parathyroid gland and the hormones that are released by them. And so here are the key terms and the key concepts which we just looked at.